Hello, welcome to 4-7. Today we're going to look at comparing and ordering fractions. And our goal is that we will be able to use pictures and number lines to compare and order our fractions. So let's get started right away. Alright, so the first one is asking us to compare 1/8 to 5/8. Write a greater than, less than, or equal statement with them. And first off, we're going to practice doing pictures. So let's start off by looking at these with circles. Let's see if I can get a circle here. And then we can be a little bit more precise, I think, with my drawings, because we all know they're not always so precise. I think about right there. Okay. Yeah, not quite, but close enough anyways. Okay, so I have two numbers, and I need to cut them both into 8 pieces. That's what our denominator says, how many pieces we cut them into. So let's cut these into 8 pieces. Luckily, 8 is an easy number to do because we can do 4, and then we've cut each of them in half. Again, it would be 8 pieces. Yikes, that last line was terrible. Looks like I am not able to move that last line. Okay, anyways, we'll have to make do. Alright, so then let's cut this one into 8 pieces as well. Thinking kind of like a pizza and cutting a pizza. That's how they usually cut round pizzas, unless you get square pieces. But anyways, so if I compared 1/8, well, that would mean I'm going to eat 1 piece of pizza from here. Okay, to 5/8. Well, I'm going to eat half, which is 4 pieces. 4 is half of 8, and then I'm going to eat 1 more piece right here. So if we had to compare them to say which number is bigger, if I ate 1 piece out of 8, or if I ate 5 pieces out of 8, we could say that 1/8 is less than 5/8. We know that 5/8 is bigger. Now a trick is, if the denominators are the same, all we have to do is look at the numerators, and that will tell us what number is bigger. So already we saw the denominators that were the same, so we would just have to look at our numerators, and 5 is bigger than 1, so we would know that 5/8 is bigger than 1/8. When it gets tricky is when their denominators are not the same. So let's look at that for the next problem. Now, another way to divvy up fractions looking at pictures is to do kind of like a rectangle and divvy them up that way. Let's see if I can get these really close. Okay, I think I got them really close to the same. All right, so let's look here. And now I need to cut this one into 10 pieces. Yikes, that's going to be tricky. All right, so 1, 2, 3, 4. I need to make 4 cuts to make 5 pieces. 1, 2, 3, 4, 5. Okay, and the reason why I chose 5 is because that's a lot easier to eyeball than 10. Now I just need to cut all these in half. 1, 2, 3, 4, 5. Now I should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, I'm not counting the lines, I'm counting the pieces. Okay, so if I eat 7 pieces, I'd eat 1, 2, 3, 4, 5, 6, 7 pieces. And I can make this a little bit bigger too, so it kind of shows up a little better. So this is how much of my pie I'm going to eat. My line, I guess I should say. All right, so now let's cut this one. 1, 2, 3, 4. Did not quite cut that one right. Anyways, so let's go through and cut these up. 1, 2, 3, 4, 5. Okay. Again, when we're talking fractions, well, and actually, you guys, I did that wrong. Let me see. Good, it doesn't erase my... I should be cutting this only in half. So let's cut it in half. So if I cut this, I'd say that's about in half. And then if I'm going to do how much I'm going to eat here, I would eat this much. So then we'd ask ourselves, okay, what's bigger, 7/10 or 1/2? Well, if we look at our pictures here, we can see that 7/10 is bigger. So if I wrote my statement, I would say 7/10 is greater than 1/2. Now, how I can always tell that again is if I look at 7/10, half of 10 would be 5/10. So if we were looking at equivalent fractions, I could say that 5/10 equals 1/2. Well, if I add 2/10 onto that, I would be having 7/10, so I would know that that would be bigger. The only thing that we need to be careful of with pictures is that we are human and we can't draw things very accurate. So it's always good to back everything up with the math. So let's go to the next slide and we can do a little bit with the math. All right, Rachel and Hannah have 1 2/3 cups of cabbage. They need 1 1/2 cups to make pot stickers. Do they have enough for the recipe? All right, so what we're going to do here is, so let's compare 1, oops, I better get my pen out, 1 2/3 to 1 1/2. So first let's start by comparing our whole numbers, because if they're different, that's the easiest way to tell which one's bigger. So if I compare 1 to 1, I would say, well, 1 is equal to 1. So that did not help us at all. So our whole numbers are the same. So next step, what we're going to do is we're going to compare our fractions. 2/3 is what they have, and they need 1/2. Okay, so the best way to do this is finding an a common denominator. That means we need our denominators to be the same. Now, I'm going to look for the least common multiple. We haven't talked about that yet. I believe that should be coming up, though, pretty soon here. Talking about the least common multiple. Looks like not this chapter, but should be coming soon anyways. So we need to find a common denominator. And I know that multiplying 3 times 2, well, really I'm asking what number do both 3 and 2 go into? And I know that's 6. So if I multiply this number by 2 and multiply the numerator by 2, I would get 4/6. So again, I'm finding an equivalent fraction and I'm trying to find the common denominator. So to get 2 to equal 6, I would multiply by 3 and multiply by 3, and I would get 3/6. Okay, so this is what I have, 4/6. This is what I need, 3/6. So do I have enough? Yes. We do have enough for our recipe. Okay, and so we only have to look at the numerators because our denominators are the same. We cut each pie into 6 pieces. This one I ate 4. This one I ate 3. Okay, so I needed at least 3, so yes, I have enough. All right, so let's look at one more problem to practice. And next one we're going to do a number line. All right, so number lines are always so tricky because we have to think of fractions as a number that's between 2 whole numbers. So all of these numbers right here are really going to be between 0 and 1. They're all between those 2 numbers. So now we have to think about, okay, let's find a common denominator for all of these numbers. Well, what number do they all go into? 7, Okay, do they go into 14? 4 does not go into 14. Does 4 go into 21? Nope, 4 does not go into 21. Does 4 go into 28? Yes, it does. Okay, so our common denominator is 28 for all of them. Okay, how do I get 7 to 28? I multiply by 4, multiply by, multiply by 4, okay? So 7 times 4 is 28, 3 times 4 is 12. So there is a 12 28th. Now to get 4 to be 28, I have to multiply that by 7. Multiply by 7. 3 times 7 is 21. And again, to get 4 to 28, I would multiply by 7. Multiply by 7. 1 times 7 is just 7. Okay, so my first step was get a common denominator when we're ordering fractions from least to greatest. Now, this does not say to do a number line, but I just think it's good to help visualize these numbers as a value between 0 and 1. So the next step, which is not going to be fun, is to split up 0 and 1 into 28 equal parts. Now that is very tricky, so we will do our best. So I'm going to start by 2, 4, 8, 1, 2, 3, 4, 5, 6, 7. Yep, 8 equal parts. Then if I cut them again, it would be 16. And if I cut them 16 again, okay, 16, let's go some of my bigger ones. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Now let's count to make sure I got them all. 1. Again, I'm counting the space in between the lines, not the lines. So that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Yes, I have 28 spaces. Okay, so now to draw my lines on here, this one, which is 3/7, I'm going to put that below so I remember that that's really what the fraction is that we need to put on, should be at the 12th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this spot, the dot on the line, is 3/7. We should put the original number on, not our converted number. Now I have to count the 21st spot. Well, if this was 12, I can just keep going. 13, 14, 15, 16, 17, 18, 19, 20, 21. And again, let's put our original number down, which was 3/4. And lastly, we have 7/28. So it'd just be 1, 2, 3, 4, 5, 6, 7. Here is our 1/4. So if we order them from least to greatest, again, make sure you read that carefully. I still have kids doing it backwards. Least to greatest is what my directions say. So I would say we would do 1/4, 3/7, and 3/4 would be from least to greatest. And again, we could just look at our converted fractions. We could see that is the smallest. Then it would be the 12, then the 21, which would be 1/4, 3/7, 3/4. We could have told it by just doing the math, but it's always good to use a number line to help prove where these numbers lie. Okay, so that is all that I have for you today. Tomorrow we'll do some more practicing with this. So I hope you have a good night. We'll see you tomorrow. Thanks for watching.